All right, so we have looked at phase difference. In fact, we ended phase difference the other time, and we ran the phase difference and got this result, which was different from the others. Today, I want to just say in passing a method known as the least squares dummy variable, regression. The least squares dummy variable regression. It's a sort of regression that is another way to account for the time fixed unobserved heterogeneity. It is one way to address that issue. So the unobserved heterogeneity is a big issue. And that is one thing that everybody is trying to handle. The time factor allows us to estimate the unobserved factors as a further beta parameters. Okay. So the least squares dummy variable is done. It adds a potentially large number of independent variables to the specification of interest. And it is believed that it's not that much inefficient way. It's not an inefficient way of addressing the issue. Having said that, I'm still going to show you how you model the least squares dummy variable regression in R. I called it WLS, W least squares dummy variable. That's how I call it. You include all the variables, okay? Include all the variables. And the idea is to deal with the unobserved heterogeneity. Okay, so how do you do that? It's already a very simple thing. You all have the commands in the lecture slides. But in my R studio, this is a command, the same command I've given you. Okay. The command is PLM command. The log of wage is explained by education, experience squared, union, married, ethnicity. And this is where the problem is. You need to include all the individual factors, okay, plus the time dummies. And there are so many, because if the observations are many, it means that all of those individual factors are going to show. Okay. And then you run that. It might not fully show all the results because it's a long thing. This is, you see how long it's taking for the results to show. Okay. So that can be very long. That can be a bit long to see the results. And there you go. Okay. So what it does is that each factor, you see if the factors are up to 4,000, maximum printing cannot even be obtained. Okay. The residual squares is 0. The residual sum of squared. The R square is 1. The p-value is not even available because in this case, the individual factors are so many. So when you go through, it takes the entire spacing of all of the information that you have. But the key point is that the idea is to deal with the individual. And so you pay more attention to the individual factors. When you have a lot of observations like this, it's not that key. I thought I would just flag that before we go to the real deal. So what is a real deal? What is a real deal?